Today we're doing complex numbers or simplifying complex numbers. Uh, so today, I don't know if you guys are familiar with this, we're going to be using the I for imaginary numbers. So I square is equal to -1, and the I by itself is equal when you have a square root with the negative radicand inside. -1 in this case would be I. And this is done because the square root of a negative number does not exist. It's not a real number. So that's why they created this, whoever did these complex numbers, where they included the I in order to work with negative radicands when you're taking the square root of that negative number. They came out with these complex numbers in order to simplify and expand in that branch of math. For example, so you have the square root. So remember, square roots cannot have negative numbers inside, at least not real ones. So this is a -36. So this would become an imaginary number. Part of it would be imaginary. So what you need to do is that negative would become this part. So this is what I mean. You would have -1 times 36. So I would just separate this one's square root of -1 times square root of 36. So now we know that the square root of -1 is imaginary because we can't have negative numbers for a square root. But using this imaginary unit, we know it's I. So this whole part will become an I. And then the square root of 36, you guys know, is 6. Alright, so we don't really write the answer like this. There's one case where the I comes first, but when you have an answer like this, they always put it like this. Or you can use both, but they like doing it like this. That would be the answer, but if you give me that, that's fine. Still the same thing. Okay, the same with this. It has a square, is a square, and is an imaginary because of the negative. So I'm going to do -1 times 5 square root of -1 times square root of 5 square root of -1 again, using these units, imaginary unit. We know this part is I. And square root of 5 is just square root of 5. And this is what I mean. When you end up with square root of 5, that's how you leave the answer. Do not give me this because, not that it's wrong, but do not give me this and then the I. Why? Because it might get confused with this. So when there's an imaginary, a radical, I mean, and an imaginary number, the I, put it in front of the radical. This is not wrong, but it might confuse people, so let's leave it like that. So that negative is outside for this one. Again, it's a square, and then we have a negative, so we're gonna have to use this. So that negative is it's outside, and then this one. So we know this part, the square root of -1 would be the I, the imaginary. So we're gonna have -I, and then we still have the 20. Now for the 20, you guys should know that we can split this one with this one before. So this would be 4 times 5. So square root of 4 would be 2. So negative 2i would be outside of the 2. And then the 5 would stay inside. And this would be the answer for this one. Okay, this is just an example, well, some notes. Should have put my little cloud. So it just says that the product rule for radicals does not necessarily hold true for imaginary numbers. And they give you an example where you have negative square root of negative 4 times square root of negative 9. You would, the negative part, you would make it into an I. And then the square root of 4 would be 2, and the square root of 9 would be 3. So again, the I is that negative part inside the square root. So now you multiply them, so 2 times 3, 6, I times I squared. I squared becomes a negative 1, and you still have the 6, right? Why I squared becomes a negative 1 is one of those units. I squared is equal to negative 1. So whenever you see I squared, that becomes a negative 1. So 6 times negative 1 gives you negative 6. This is the correct form. And it doesn't, the product rule doesn't necessarily hold true for imaginary number, because if you have the same example, negative 4 times square root of negative 9, and you would apply the rule where you put these two inside, then you would have two negatives inside, and then you would think, oh well, negative times a negative would become positive, and you end up with a positive answer, negative 6, which is wrong. Because to start with, you had an imaginary part in this square root. If it was by itself, it's not possible to solve this. That's why you use the imaginary numbers. So this would be wrong when you see a negative inside and you're dealing with even roots like square root. So let's do example 2. So it's more the same, except now you have two radicals. So you would do the negative 1 times 3, the negative 1 times 5, and I'm going to check the extra steps. So these would be separated like this, times like that. So don't forget that I squared equals 1, and I is equal to the square root of negative 1. Right? So the units. I squared is negative 1, sorry guys. Negative 1. I squared is negative 1, and I equals the square root of negative 1. So that means this part, these two parts, become I. So this becomes I, that one stays the same. This becomes I, and that one stays the same. Okay. So now we have I times I becomes I squared, and then square root of 3 times square root of 5. Now since we don't have the negative anymore, now you can apply the product rule for radicals. So you would have I squared 3 times 5. Now I squared, what's I squared? Negative 1. So you would have a negative 1. 3 times 5 would be square root of 15. And you don't need that in 1. You can have a negative just like that. Because the 1, you know 1, it's already here. Like, it's implied that it's here, and then you would leave this one because we cannot simplify it further. So, but if you give me that answer, that would be fine. But it looks better like this. So that would be the final answer. Okay, for this one, so again, I'm gonna separate that negative. So that's negative 1 times square root of 36 times square root of negative 1 times square root of 1. And you know that these two become I. This becomes 6, right? Square root of 36 is 6. This becomes an I again, and this one becomes a 1, right? 1 times 1 equals 1. So now I just put them together. So I times I is I squared. 6 times 1 is 6. So 6, what's I squared again? I squared is negative 1. Negative 1, so you end up with negative 6. 6 times negative 1 equals negative 6. So that would be B. Now let's do C. So C, so this one you can simplify further. It doesn't have a negative, but you can do 4 times 2 square root. That one you would have to separate the negative times that. So square root of 4 would be 2 square root of 2 inside, right? You can find the square root of 2 times, and then I'm going to separate this one. Negative 1 times square root of 2. So 2 square root of 2 times, what's that? The I, right? Don't forget I equals square root of 1. And that one stays the same. So now 2 times I is just I. And then we have square root of 2 times square root of 2. So 2I. They're positive now, so we can put them together using the product of radicals. Product of radicals. So this would be 2I. 2 times 2 would be 4. Square root of 4 would be 2. So 2I times 2. And now simplify 2 times 2 would be 4I. I could have solved this like really quick, but I'm just showing you all the steps. 4I. Now this one. So again, I'm gonna separate. Then okay, so negative 1 times 125 over square root of 5. So square root of negative 1 times square root of 125 over square root of 5. So this part becomes an I. And then you have square root of 125 over square root of 5. And since they're both positive now, you can use the rule. The quotient rule or product quotient rule of radicals. It would be the same. You could put them together inside the radical like this. And this would give us 25 over 5 would give us 25. So square root of 25 would be 5. Remember, it's already labeled like that, but it looks a lot better when you do this. 5I. When it's a number, when it's a radical, leave it in front. The imaginary I, leave it in front of the radical. Okay, that's example 2. I'm gonna do example 3 and then I'm gonna stop. Let's see, I should stop and then I'll do the other one. So now we're dealing with complex numbers, the actual complex number. So a complex number is a number that can be written in the form So this is the form A plus BI. A and B are real numbers. They're just one, like a 2, any number. And that would be the imaginary part. So this is sum or differences of complex numbers. So now we're adding or subtracting complex numbers. If A plus BI and C plus DI are complex numbers, then their sum is, so we have this, so all the letters are, except for the I, that's imaginary, but this would represent numbers. So all you're doing here is you would have the I outside and you would add this and this. But I think I'm gonna show you how this works. And that's just the rule. They're kind of confusing. I don't want to confuse you with this. So let's do them. So 2 plus 3i bt. So basically, well, let me explain what happened. Basically, all they did was regroup. Like they changed the group, so they use the commutative and the associative property. They regroup this with this here, and then they regroup the numbers here. That's all I did, but let me show you how I would do this without all the confusion. So you would just put 2 plus 3i plus minus, so you know you're going to get minus 3 plus plus, so plus 2i. So you're basically combining like terms. So we're combining the 2 and the negative 3. So you would have 2 minus 3, and we are combining this and that, plus 3i plus 2i, and this would just be negative 1 plus 3i plus 2i would just give you 5i. And that's it. And you didn't have to do that. You could do 2 minus 3 is negative 1. 3 plus 2i would be 5i. That's what I'm going to do here. So this one, you would have the 5i. You would have negative 1 and positive I. So now the negative 1 would go in front, because that's how complex numbers go. The number goes in front first, and then the imaginary part comes second. The negative 1 in front, the number, and then 5i plus 1i gives you 6i. And that would be the answer. So again, this one you could have just done it like 2 minus 3 would be negative 1. 3i plus 2i would be 5i. Positive, right? Because they're both positive. That's all you need to do. For this one, so you would have negative 3, negative 7i. Negative times a negative would be positive 6. So combine the like terms. So combine these two. Negative 3 plus 6 would be positive 3 minus the 7i. And that would be the answer. And I'm going to stop there for this video.